All right, so in relation to covalent bonds, the course does take you through Lewis structures. All right, these really are not bad at all. The purpose of a Lewis structure is to kind of help you see how the sharing in covalent bonds might happen. But for the purposes of this class, really all you got to do is be able to draw a Lewis structure of an individual atom. So, we've seen this before, and we've really focused in heavily on the ion pattern for the group A elements, because that was helpful for figuring out what's going on with ionic bonds. That ion pattern comes from the starting point, the valence electron pattern. All right, so we talked about this in Unit 3. It's just we haven't repeated it again, so it's probably not sticking out in your mind as much. But if you remember, so we have 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. All right. And the valence electron pattern, all right, is exactly those numbers. All right. The number of the A column tells you how many valence electrons. All right. So, whereas the ion pattern, that comes from, when you're trying to form ions, what you're going to do with the valence electrons. All right. So the ion pattern was a different thing. That's that whole +1, +2, +3, plus or minus 4, -3, -2, -1, or 0. All right. So the ion pattern, that's for ionic bonds. The valence electron pattern, that's useful for covalent bonds. All right, both of these patterns are something you should be familiar with. All right, so just keep that in mind as you're dealing with things. If you're dealing with ionic bonds, you want to focus in on the ion pattern. If you're focusing on covalent bonds and you're asked to draw a Lewis structure, you want to focus in on the covalent bond valence electron pattern. Okay? So, the valence electron pattern tells you that everything in group 1A has one valence electron. Everything in group 2A has 2 valence electrons. Everything in group 7A has 7 valence electrons. Up to 8 valence electrons in the noble gases, which is a full octet, and that's why the noble gases don't react. All right, when it comes to drawing a Lewis structure, you just have to look up where that atom falls in the periodic table. All right, so like oxygen falls in group 6A, so we know it has 6 valence electrons. When you draw these, all right, these are already drawn, but if I was doing this by hand right now, oxygen has 6 valence electrons. The way you're supposed to do this is you start by putting 1 electron on each side. All right, so there's 4. And then you start pairing them up. All right, so like say for example, carbon. Carbon has 4 valence electrons. Its Lewis structure would look like this. 1 electron on each side. Hydrogen. Let's go with hydrogen. Hydrogen has 1 valence electron. It would look like that. All right. Let's see. Aluminum has 3 valence electrons. It would look like this. All right, so just remember you're going to draw 1 on each side first, and then you start doubling up. So try practicing this. See if you can get the Lewis structures drawn for these chemicals. All right, so we've already done hydrogen. All right, I'll do a couple more on here. Let's see, I'm going to do nitrogen because that one's already done again on the other slide. We'll do silicon, iodine. So if you want some guided practice, pause the video and then start it back up, and then you'll see what the correct answers are there. If you're still a little shaky on it, you can start watching while I go. But this is definitely something you'll want to be able to do on your own. So nitrogen is in column 5A. So 1, 2, 3, 4, 5. Where you pair up, where you start your first pair really doesn't matter. Or where even you start your first dot. But it should be 3 solo electrons and 1 pair. Silicon is right below carbon. So that's going to be, I don't know why I just drew carbon. The symbol for silicon is Si. And it's going to have 4 valence electrons because it's in group 4A. Iodine is in group 7A. So there's the symbol for iodine. And I've got 1, 2, 3, 4, 5, 6, 7. All right, so you should, this one, as long as you have 3 pairs and 1 solo electron, you did it right. All right, so if you have questions about these, let me know. Otherwise, we're all done.